Look up at the night sky on a clear, moonless evening. The canvas of the cosmos stretches out in every direction, a glittering tapestry woven from billions of ancient suns. It is a view that has inspired human imagination for millennia, whispering promises of infinite possibilities and uncharted worlds. Yet beneath the breathtaking beauty of this stellar expanse lies a chilling, deafening silence. In a universe so unfathomably vast and ancient, teeming with the raw ingredients for biology, we find ourselves seemingly completely alone. The numbers defy human comprehension. Our observable universe spans some 93 billion light years across, containing an estimated 2 trillion galaxies. Our own Milky Way galaxy alone harbors between 100 billion and 400 billion stars. Given the 13.8 billion years since the cosmos burst into existence, there has been ample time for matter to coalesce, for worlds to form, and for the spark of consciousness to ignite countless times over. The mathematical probability dictates a universe crowded with voices, yet our radio telescopes hear nothing but the crackle of dead static. This profound contradiction was famously articulated in the summer of 1950 by the brilliant physicist Enrico Fermi. During a casual lunch conversation about a recent cartoon depicting aliens stealing New York City trash cans, Fermi performed a quick series of mental calculations. He considered the age of the galaxy, the number of stars, and the time it would take a civilization to traverse the interstellar void. His conclusion was startlingly simple, culminating in a question that would haunt astrophysics for decades to come. Where is everybody? That simple question gave birth to what we now call the Fermi Paradox. It is the jarring disconnect between the high probability of extraterrestrial intelligence existing and the complete lack of observable evidence for it. If interstellar travel is possible, even at a fraction of the speed of light, a moderately advanced civilization could colonize the entire Milky Way in a few million years, in cosmic terms. A few million years is the blink of an eye. They should already be here, or at the very least we should see the towering monuments of their engineering. To quantify this mystery, astrophysicist Frank Drake formulated the Drake equation in 1961. This probabilistic framework was designed to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way. It multiplies a series of variables, starting with the rate of star formation, narrowing down to the fraction of those stars with planets, and the number of those planets that could potentially support biology. It then factors in the emergence of life intelligence and the capability to transmit signals into the deep dark. For decades, the variables within the Drake equation remained purely speculative. But a revolution in modern astronomy has dramatically altered the landscape. Our space telescopes have discovered thousands of exoplanets orbiting distant suns. We now know that planets are not a cosmic anomaly, but a standard feature of stellar evolution. Current estimates suggest there could be as many as 40 billion Earth-sized planets residing in the habitable zones of their host stars within our galaxy alone. The staging ground for life is ubiquitous, making the perplexing absence of alien signals even more agonizing. If the universe is a fertile garden, why are there no other gardeners? We have
Yeah.
scanned the electromagnetic spectrum for decades, searching for intentional beacons, the leakage of alien radar, or the spectral signatures of industrial atmospheres. We haven't found a single trace. We have looked for megastructures, artificial constructs large enough to dim the light of a star, and still we see nothing. This void of evidence demands a powerful explanation, a mechanism capable of silencing a galaxy that should by all rights be singing with life. In 1996, economist and polymath Robin Hanson proposed a terrifyingly elegant solution to this cosmic riddle. He introduced the Great Filter hypothesis. Hansen suggested that somewhere along the evolutionary path, from the formation of a rocky planet to the rise of an interstellar empire, there exists an incredibly improbable step. This step acts as a massive bottleneck, a barrier so difficult to overcome that it practically reduces the number of successful civilizations to zero. The Great Filter represents a series of evolutionary hurdles. First, the right star system must form with a habitable planet. Then reproductive molecules must self-assemble from dead chemistry, an event known as abiogenesis. Simple single-celled life must eventually evolve into complex multicellular organisms. From there, animals with large brains must develop tool use, language, and civilization. Finally, that civilization must survive its own technological adolescence to colonize the stars. The filter is the one hurdle in this sequence that is almost impossible to clear. The most crucial question for humanity is where this evolutionary bottleneck resides. If the great filter is behind us, hidden in our deep past, it means we have survived an ordeal that trillions of other worlds failed. Perhaps the leap from non-living matter to the first living cell is an astronomical fluke, or perhaps the transition from simple prokaryotic cells to complex eukaryotic cells, which took billions of years on Earth, is the true barrier. If the bottleneck lies in our rearview mirror, humanity is the beneficiary of a spectacular cosmic lottery. It would suggest that Earth is a rare jewel, a freakish exception to the rule of a barren universe. In this scenario, we are likely the first and possibly the only technologically advanced species in the Milky Way. The silence of the stars is not a sign of failure, but a testament to our unique triumph against impossible odds. There is a profound sense of loneliness in this realization, but also an overwhelming weight of responsibility. If we are the sole torchbearers of consciousness, the only universe that has awakened to observe itself, then our survival is of paramount importance. Every war, every conflict, every existential risk we take threatens to extinguish the only spark of meaning in an otherwise cold and unthinking void. The preservation of our species becomes a sacred duty to the cosmos itself, but there is a darker, far more unsettling alternative. What if the great filter is not behind us? What if the incredibly improbable step lies in our future? This scenario paints a grim picture of the universe. It suggests that life routinely emerges, evolves, and builds complex civilizations, but inevitably hits a wall before it can spread to other stars. The filter waits patiently ahead, a silent executioner of advanced species under this terrifying paradigm. The universe is essentially a graveyard of failed experiments. Civilizations might naturally discover technologies that outpace their wisdom. The power to split the atom, to engineer deadly pathogens, or to create artificial superintelligence might be universal milestones. If every civilization eventually invents the tools of its own destruction, and if the impulse to use them is unavoidable, then the great filter is simply the tendency of intelligent life to commit planetary suicide. Imagine the countless worlds that might have reached our level of technological prowess. They built sprawling cities, harnessed the power of electromagnetism, and looked up at their own night skies with the same wonder we do. Yet somewhere between launching their first satellites and colonizing their neighboring planets, they vanished. Their ruined monuments now drift silently around alien suns, slowly being ground to dust by the relentless march of deep time. We can look to the Kardashev scale to understand what we are failing to see. A Type 3 civilization on this scale would have harnessed the energy output of its entire host galaxy. They would be rearranging star systems, building Dyson spheres to capture stellar energy, and emitting colossal amounts of waste heat detectable across the universe. The complete absence of such godlike entities suggests that the transition from a planetary civilization to a galactic one is where the filter drops its heavy blade. This is why the search for simple life on other planets carries such a heavy burden of dread. If we were to discover fossilized bacteria on Mars or swimming microbes in the subsurface oceans of Europa or Enceladus, it would be a monumental scientific triumph, but it would also be terrible news for humanity. Finding life easily in our own solar system would imply that the leap from dead matter to biology is common, pushing the great filter further into our future. The more complex the life we find, the worse the implications become. If we were to discover the ruins of a dead alien civilization on a distant exoplanet, it would all but confirm that the filter is ahead of us. It would mean that surviving our technological adolescence is the exception, not the rule. Every new discovery of a habitable world that turns out to be dead increases the tension, tightening the invisible noose of the Fermi Paradox around our collective future. We stand at a precipice in our evolutionary history, balancing precariously between the mud of our origins and the starlight of our destiny. We have the power to alter our planet's climate to rewrite the genetic code, and to leave our footprints on other worlds. Yet we remain bound by our primal instincts, capable of unleashing devastation on a planetary scale. The great silence we observe is a mirror, reflecting our own fragile existence back at us. The cosmos watches, utterly indifferent to our struggles, waiting to see if this profound mystery will ultimately challenge us to survive, or if we will fade into the silent dark. The Fermi Paradox and the Great Filter are not just abstract intellectual exercises, they are the ultimate test of our species. As we gaze into the cosmic vault, we must choose whether we will become the rare exception that breaks through the barrier, or just another quiet ghost haunting an empty galaxy.